Good morning, students. Today I will discuss electrostatics. A short discussion or a brief review about the subject. Okay. What is electrostatics? We all know, where the charges are in stationary condition. Charges are in stationary conditions. In most of the cases, we use certain capacitors where charges remain in stationary condition. Now I will write some basic formulae. Thereafter I will do some problems. Okay, what are those basic formulae? Formula number 1, very easy formula, that is Coulomb's law. F equals to, formula number 1, F equals to Q1 Q2 by 4 pi epsilon naught r square. You know, two-point charges are separated by certain distance. The linear distance between the two is r. Then this is the formula. These are two-point charges and this is Coulomb's law. And what is the meaning of in SI system? In SI system we may write this. In SI system we may write this formula. Okay, this is F. Nothing but F equals to this force. Force of either attraction or repulsive. You all know that similar charges repel each other and opposite charges attract each other. Now I may write 1 by 4 pi epsilon naught equals to 9 into 10 to the power 9 Newton meter square Coulomb to the power minus 2. This is the value of 1 by 4 pi epsilon. And you should know that epsilon is the permittivity in free space. Permittivity in free space. Okay, and what is the dimension of this? You know, Newton. Newton means m l t to the power minus 2. You just take a note. M l t to the power minus 2. M square means L square. C means Coulomb. Coulomb means I into t to the power minus 2. Because we all you know that q by t equals to I. So Q equals to I into T. As you know, C is in Coulomb, then I into T. Okay. Then I may write like this: M L Q T to the power minus 4 I to the power minus 2. This is the dimension of 1 by 4 pi epsilon naught. This is the dimension of this. Very important relation. You have to remember this one. This is dimension. This is dimension. This is dimension. This is dimension. Okay, am I clear or not? You follow me? Then this is dimension. Now I will go for the second one. Another problem. Then another equation I am going to write. That is what? That is actually electric field. You know what is electric field or field intensity? Suppose a charge is there in space. A amount of charge is there in space. That is a cube dash amount of charge is there. And the region that is being influenced by it is electric field. Electric field. The region that is being influenced, if certain amount of charge is kept in space, the region that is being influenced by it is called electric field. And what is field intensity? If a unit positive charge is kept at a distance r from q, then we may write electric field intensity E equals to q. What can I write? That is here it is cube dash. Here you can write cube dash into 1 by 4 pi epsilon naught into r square. Or you may write, you may consider cube dash equals to cube. You may write also cube dash equals to cube. If you say this is cube dash equals to cube, then you may write what? You can write E equals to cube by 4 pi epsilon naught into r square. This is the force. When a unit positive charge is kept at a point P, then force realized by it is then the force realized by it is called electrical field intensity. It's called electrical field intensity. Now this is E equals to this one. Okay, clear? This is the force realized by unit positive charge. It's called intensity. And if it, instead of writing this, if it is cube amount of charge is there, if cube dash amount of charge is there, then force will be equals to cube dash into E. Then what is the formula? Then the second formula is that what is F equals to cube dash into E. That is what? That is charge into field intensity. Charge into field intensity. This is another formula. Okay, clear? What is the value of, what is the unit of E? Electrical field intensity. E is nothing but F by Q. F means Newton, Cube means e to the power minus 1. Okay, Coulomb to the power minus 1. What can you can write, what is the dimension of this? Dimension is ml t to the power minus 2, I to the power minus 1, t to the power minus 1. So what you can write? You may write ml t to the power minus 3, I to the power minus 1. This is the dimension of electrical field intensity. Okay, clear? And what is the unit? This unit, SI unit is SI system. This is the second formula. Okay. Now I am going to write the third one. This is very important for solving the problems. If you want to solve the problems, you should know the basic formulae. Then you can proceed. I will do some problems, and you will be able to understand that it's very easy. And this is the second formula. Okay. And what is the third formula? What is a potential? If a unit positive charge, suppose here you consider here is a charge Q, and this is the region that is in infinity. If a unit positive charge is kept at infinity and it is brought at a point R from infinity, then the work that is to be done is called potential at that point. So what is the definition of potential? If a unit positive charge, if a unit positive charge is brought from infinite to a point in the electric field, the force to a point in the electric field, the work that is to be done is called electric potential at that point. What is the mathematical relation? V equals to Q divided by 4 pi epsilon naught R. This is the relation. What is the relation? If you consider it as Q, then this will be V equals to Q by 4 pi epsilon naught R. What is the unit of potential? Volt. Unit of potential is volt. In which system? In SI. In SI system. In which system? In SI system. What should be its dimension? You know, the volt means Coulomb by meter. That is Coulomb meter to the power minus 1, isn't it? Coulomb meter to the power minus. Or what you can write? You are able to write W equals to cube V. What is W equals to cube V? W, if unit amount of charge is brought from infinity, then it is V. If Q amount of charge is brought, then it is cube V. What is the unit of volt? Volt equals to W by Q. What is the unit? W by Q. W is a unit of, in SI system, joule. W will be written in SI system, it is joule, and it is, and in Q it is Coulomb. So it is joule Coulomb to the power minus 1. What it is? Joule Coulomb to the power minus 1. Okay? Or you can write volt. Volt is nothing but this one. What is its dimensional unit? Joule, you know, m L square T to the power minus 2, and Coulomb means I to the power minus 1 T to the power minus 1. Then what you can write was the dimension m L square T to the power minus 3 I to the power minus. This is the dimension. Okay, you take a dimension, write a dimension. Then you know all about potential, electrical field intensity, and Coulomb's law. Okay, these are the very important relations that you have to know. Otherwise, you can't solve the problem. Okay, I will do one problem, so two problems. Then you will be able to know how easy this subject is. Now, you know, all of you have understood this one, na? Then I should say what is the relation? What is Gauss's law? Gauss's law. What is Gauss's law? Gauss's law is nothing but E dot ds equals to Q by epsilon naught in which system? In SI system. In SI system. In which system? It is Gauss's law. It is called Gauss's law. In case of statical electricity. Electricity. Okay. You know, this is in SI system. And suppose there is a sphere. Okay. Suppose it is a sphere. And if you consider it a Gaussian surface, means this is a Gaussian surface, then this one is lines of force will emit perpendicularly to this point, from this point. Okay, this Gaussian surface means what is the radius? Radius of this sphere is r. Okay, clear? Then what you can write? What is its area? E into A, E into S equals to cube by epsilon naught. E into S means 4 pi r square equals to cube by epsilon naught. Am I clear or not? Clear? Then what you can write? You are able to write like this: cube by 4 pi epsilon naught r square. And this resembles to that of the relation that I derived earlier. So E equals to cube by, from this Gaussian surface. This is actually Gaussian surface. What surface? Gaussian surface. What surface it is? Gaussian surface. Am I clear? This is called Gauss's theorem, and this is called Gauss's theorem, Gauss's law, in case of electricity and statical electricity. And you all know, I have already told you that like charges repel each other and unlike charges attract each other. Okay, I have already told you this. Now what I should write? I will write some relation. Suppose there is a dipole. What is dipole moment? P equals to Q into twice L. This is the relation of dipole moment. Okay, in case of electricity, this is called dipole what? Dipole moment. And what you can write? 12 tends to 0, where the distance between two plus q and minus q. If the distance is very small, then you can write this is dipole moment. Okay, the dipole moment. And what is tau? Tau is nothing but equals to P cross E. Tau is nothing but equals to P cross E. Tau is torque equals to P cross E. Okay, how I have done it? This is actually, these are the lines of forces. These are uniform field. What type of field it is? Fields may be of two types. One is uniform and another is non-uniform. This is uniform field. And if a dipole is kept here in this way, then what you can write? This is E. This is E, dipole. And the force will act in this way. This is plus Q and this is minus q. So what is the length of this? This is x, and this is actually 2L, and this is theta, and this is also theta. Then what is tau? Tau means nothing but torque. Torque is nothing but this is QE, and also this is QB. Parallel forces and perpendicular distance. Parallel forces and perpendicular distance is x. What is parallel forces? Q into E. And perpendicular distance is x. Perpendicular distance between them is x. Then what you can write? You may write QE. X means perpendicular by hypotenuse. X by 12 equals to sine of theta. So you can write 2L sine of theta. What you can write? Q into 2L into E into sine of theta. So this is clear. PE sine of theta. That means P cross E. That means P cross E. If E equals to 1 and theta equals to 90 degree, if an electric dipole is kept perpendicular to electric field, the mechanical couple which is required to keep that needle in that position is called dipole moment. It's called dipole moment. So if a electric dipole is kept perpendicular to a electric field with intensity 1, okay, the mechanical couple that is required to keep its position is called dipole moment. So you can write E equals to, then you may write tau equals to nothing but equals to P. Tau is nothing but equals to P, because E equals to 1, sin theta equals to 90 degree, sin 90 degree is 1, so this is P equals to 1. What type of vector it is? It is called axial vector. What vector it is? Axial vector. Okay, axial vector. So I am wiping out this portion. Okay, now you see what I can write here. It is very easy to understand, that just to see how I can proceed. Now let me describe end on position and broadside on position. Suppose it is end on position. Suppose a dipole, this is plus q and this is minus q, and in end on position, if it is R and this is 2L, then what you can write? E resultant is nothing but equals to twice PR divided by 4 pi epsilon naught R square minus L square, what? R square minus L square whole square, isn't it? R square minus L square whole square. So is it clear or not? R square minus L square whole square. And what you can write? If R square is very greater than L square, then you may write ER equals to twice P by 4 pi epsilon naught R cube. Okay, this is end on position, and this is for a small for a dipole with very small distance between the two poles, between the two charges. Okay, unlike charges. And what is perpendicular dissector position is that this is the perpendicular bisector position, and what will be the resultant? You can write here in this way: ER, this is axial A, this is perpendicular bisector. What you can write? You can write P by 4 pi epsilon naught R square plus L square to the power 3 by 2. And if R square is very greater than L square, then you may write ER PB, perpendicular bisector position, it is equals to P by 4 pi epsilon naught R cube. Am I clear or not? So these are important lessons you have to remember, and on the basis of these relations you can solve all the problems that are available here. Okay, clear? This is for a dipole for axial position, and this is a dipole for perpendicular bisector position. This is P. Here plus 1 charge is kept. Here also plus 1 charge is kept. Okay, clear? Now I am going the third question. This is the problem that is depicted on the board. I will solve the problem. You just see how I can solve this problem? Very easy. You see, two balls of same mass are carrying equal charges are hung from a fixed support of length L at electrostatic equilibrium, assuming that the angle made by each the thread is very small. Okay, very easy. Why it is small? You see here, this is very important. Also, this problem is important. Why? You will see. Suppose these two threads of length what? L, and what you can write? This is perpendicular bisector position. This is perpendicular, and what you are seeing, when charge is here, two charges. What type of charges? Same mass carrying equal charges. That is, both are having same charges Q. What is the distance between them? Distance between them is what? The distance fixed length is L, and distance between them is x. Distance between them is x. Am I clear or not? Then, if it is 2 theta, if it is very small, then this is also theta. Okay. If it is 2 theta, then this will be theta and that will be theta, because it is a bisector. This angle has been bisected. So what can I write here? You can write, you see here, if it is tension T, okay, tension T, and there are two forces. One is due to weight and another is due to repulsive force. Repulsive force, they are repelling each other, repulsive force. So this is Fr, repulsive force. So what is repulsive force? Fr is nothing but Q square by 4 pi epsilon naught x square. This is repulsive force. Am I clear or not? And this is repulsive force. And the repulsive force is balanced by what? If it is theta, then this is also theta. Okay, if this is a parallel, this transverse. So this is a T sin theta, na? This is along this T sin theta. So T sin theta balances Fr. That will be T sin theta. Okay, and T cos theta equals to mg. Am I clear? So if you call this equation number 1 and this one equation number 2, then you can write 1 divided by 2, equation 2. Okay, equation 1 divided by equation 2. What you can write? Tan theta, na? Sin theta by cos theta. Sin theta by cos theta. T will cancel out. Okay, then what you can write? Sin theta by cos theta. That means Q square by 4 pi epsilon naught x square by mg. Am I clear or not? This is tan theta. If theta is very small, if theta 2 theta tends to 0, then theta tends to 0, then you can write tan theta is nothing but equals to sin theta by cos theta. Am I clear? Then if theta tends to 0, then sin theta will be approximately equals to theta and cos theta will be approximately equals to 1. Am I clear? So at that point of time you can write tan theta equals to sin theta. Tan theta equals to sin theta. So instead of writing sin theta, you can write here sin theta. What sin theta is? Q square by 4 pi epsilon naught x square mg. And what is sin theta? Sin theta is nothing but, this is sin theta. Sin theta is nothing but what? Sin theta means what? Perpendicular by hypotenuse. Perpendicular means x by 2. Perpendicular means x by 2. What is sin theta? Perpendicular x by 2 divided by hypotenuse means L. Isn't it? This is angle. Perpendicular by hypotenuse means L, as sin theta equals to tan theta. Why sin theta equals to tan theta? Because they have told here, what they have told, separation between the balls. You have to find what? Electrostatic mode, assuming what? Equal charges. At electrostatic equilibrium, the angle made by each other is very small. That is why theta tends to 0. What you can write? You were able to write x by 2L. What you can write? X by 2L. So what is the relation? This is the relation, na? This is the relation. So what you can write? Q squared. What you can write? You may write Q squared by 4 pi epsilon 0 mg into x square equals to what? Equals to x by 2L. What they want from you? X between the ball is proportional to x between the ball, and you can write x cube equals to L. This is 2. So Q square by twice pi epsilon naught mg. Okay, mg. Sorry. This is not that. 4 pi epsilon naught mg, and this is 2 and 2 will cancel out. Okay, and what you can write? You may write here what? You may write x cube equals to L will go on the denominator, on the denominator and the numerator, on the numerator, and what you can write? L into Q square by twice pi epsilon naught mg, isn't it? And this is constant, na? This is constant. Sorry, this is constant. This is constant into L. So x equals to another 1 by 3 L to the power 1/3. So x is proportional to L to the power 1/3. You see which one is right? X is proportional to x to the power 1/3. Sorry, x is proportional to L to the power 1/3. Am I clear or not? So in this way you can solve this problem. This is very easy problem. This one is very easy one. Take a photograph of this one. Okay. Then this is very important problem.